So a few days ago, we were talking about exponentials, and we just were talking um, about the coronavirus outbreak. And as we can see, well, we started 17th of March. We fixed we set zero as March 17th because that was actually the last day we had data on. So we modeled the function using this 1.3 that we gathered from the previous days. More or less was the multiplier that we were observing, right? And we computed how many corona virus cases we'll have after a week, right? Well, if we look at March 17th, that's that's 3 days ago, right? So March 17 was a Tuesday. Today is a Friday. So let's see what our model predicts for today, Friday. Okay. So again, the way we do this is the coronavirus cases for. So today it's day 3, which is March 20, right? So that would be a 3 here. So we have 6,411 times 1.3 to the power of 3, right? And if we actually do this calculation with a calculator, so it's a 3 here, we have a 3 instead of we have a 3. So let's see. So we have so 6,411 times 1.3 to the power of 3. So that would be 14,084 cases. Okay, that's it, the total. Now let's see what it has happened so far. Let's see where we now. So if we look at where we right now, let me set this properly before I can proceed. So right now, let's see. So we had 6,411 the day after 9,000. So this was Tuesday, Wednesday, and then Thursday, which was yesterday. It's 13,780 now. So it's actually this is over our predictions because today we already have near 3,000 cases. So that's gonna raise up to 16,000. So it's even growing more of what we expected. So that means that probably next Tuesday we're gonna have a lot more than 50,000. That was our prediction at first, right? And then we asked ourselves, okay, so how long is it gonna take to have 1 million cases in the US, which is already quite a lot of cases. So let's have a look at this. How do we solve? Now we know how to solve these type of equations, right? First, we need. Let me find the paper. I don't find that paper with the equation, but then we can build it again if we don't find it. We do not, so we're gonna build it again. Remember, we have so b to the x equals y, remember? And then the way we write it is x equals log b, which is the base of y, right? So first we need to have an equation like this with only the base and the exponent, base and exponent. So this is annoying us, so we need to get rid of it. So what we're gonna do is we're gonna divide both sides going to divide both sides over 6,411. Okay? So when we do that, this is going to cancel out. And then we're going to have, let's see, we're going to have in one side of the equation, it's 1,123,123 over 6,411. So we have 155, it's almost 156 because it's 0.98, so 156 equals 1.3 to the power of 3, right? Now is when we have this equal to this, so we can set the log equation. So x equals log, what's the base? The base now is 1.3. And then y is 156. So now we can do this with a calculator. So we have alpha window log base 1.3 1.3 is the base, and then 156. So that means it's gonna take 19 days to have 1 million of people infected. So that's what we're trying to avoid, having all those people infected. But then the next thing we could do is how long it's going to take to infect all the people on the US. So how many people do we have in the US? So approximately in the US we have 330 million people, 330. So if we do the same logic, right? If we do the same reasoning, we're gonna get that it's log 1.3, and here, right, we're gonna use this instead of 1 million. We're gonna do 330 million people, right, over 6,411. We're gonna do the same calculation. We're gonna have, let's compute it. So 330, so I'm gonna do it directly. So log alpha window log base 1.3 and 330 million, so 123 over 6,411. So it would take 41 days. 41 days to get everybody. So that's actually a month and 11 days, right? So it's crazy to think that in a month and 11 days, if we do nothing, everybody in the US would be infected. Okay. Now the last thing I wanted to do is, which is interesting, is how long does it take to double? So if we think about it this way, I think it's we humans, our mind is not prepared to understand exponentials. So how long is it going to take to double? So that's a good practice to do. So imagine I have coronavirus cases. Okay, doesn't matter how many we have, and this is coronavirus cases the initial amount. Okay, then we're going to write the same equation we had before. Okay, so imagine that we think about double. If this is the final amount and this is the initial amount, if we think about how long is it going to take, how many days is it going to take this to double, is whenever this is double than this. Okay, it's that's going to be done. So if we divide this over initial amount of cases, which this cancels out. We have coronavirus cases over the initial coronavirus cases equals 1.3 to the power of d, right? And what we're saying is, how many is going to take this to be 2? That means double. Between this and this, double. So that's 2. 1.3. If we do the same, exactly the same math, base, right? 1.3. This is y, which is 2. Oh, sorry, instead of x is d, right? Using x, but it should be d. So let's see. So we're going to have log, so alpha f2 log base, and we have 1.3, and then we're going to have 2. So it takes 2.6 days to double. That's how many days so if that means that if we have today 10,000, in 3 days we're gonna have more than 20,000. So that's, and if we have 2 million, in less than 3 days we're gonna have 4 million, right? So more than 4 million. So now last thing I wanted to do is, okay, if that's 2.64, that means that is 0.64 off a day, which is 24 hours. So that means it's 2 days and 15 hours, more or less, to double. Okay, so that's a day and a half, right? Great. Thank you.